Uh, okay. Hello everyone. My project's name is an smart auto shutter controlling system for intelligent home based on database analyzing and mechanical devices. This is my personal information. This is my often used nickname. I'm from Southern California. I would like to first introduce my demonstration video. Okay, that's the demonstration video. And I want to briefly introduce my project. So my project name is a smart auto shutter controlling system for intelligent home based on database analyzing and mechanical devices. So briefly, my project is a smart system used to control the window shutter smartly. My project is based on hardware and electronic development directions. So there are programming and software study during the project in the developing process as well, including in the Android Studio and the Raspberry Pi. The three major part of my project are mobile app controlling, Raspberry Pi hardware controlling, and firebase database and storage. And I would like to notice that by using the solar energy to power the integrated controlling system, we want to keep the idea of saving energy and being environmental friendly. On the other hand, automatic shutter can keep the balance of natural light and light bulbs in a home, which can not only save electricity but also sufficiently use the sunlight energy at home, which is also benefit for physical health. So let's start the introduction to three parts of my project. The first part is the mobile app controlling. The mobile app controlling is also called the terminal application. So I use Android Studio to create the application on the emulator. The major function of the terminal application is additional way to controlling the project. And the users could use this application on their terminals, such as their phones, or their pads, using apps to control the existing devices remotely, as shows in the video. Therefore, there will be more choices for the users to control the control the shutter. It will contain the sign up page, login page, home page, device page, registered device page, and control page, in order to fulfill functions of the terminal application. And the second part is the Raspberry Pi hardware controlling. As a demonstration, I used the winches and line system to control the shutter, which show the evolution of the motor action system that is not limited by the angle of the shutter, moving freely and stable. In fact, because of the existence of the homing button at the top and the bottom of the shutter, it will be the last insurance of the moving system. Keep it away from the mechanical destruction. And so there will be less problems during the moving action in the hardware. And there are several electronics in the Raspberry Pi system, such as the ADC signal changes system. It is used to change the data from the light sensors and temperature sensors to Raspberry Pis to be a usable data for the Python code. So in the Raspberry Pi, I use Python to create a specific code to control the system in the action in the mechanical actions. So the third part is the firebase and database storage part. So in this part, we saving the data in the firebase database, which is an open platform for every developers in the data science. It is most developed and the evolutionary part in my project. So data science provide access to the solution to keeping track of the data from the nature and light bulbs, which corresponding to the outer light sensor and the inner light sensors, and remain records of the data which lead to moving or any problems. And the server and database component experienced by the Firebase using the server to upload and download the data to the component which is needed in the system. So you can think that the server would be the platform as the bridge to and storage component to the in this project. Because of the big data technologies, the server and data science like that, the Firebase would be able to memorize the interests of the customers and provide better service of the systems. And these are some picture screenshots from my mobile applications and the database server. So as you can see, I named my project Spotter, which is actually a nonsense words. And this is sign up page using your emails and create your own passwords, and device page is used to storage all your device informations. And if you click that, you can enter to this page. This page is the a device control page. Used to control the device, whether to switch auto mode and manual control mode, and moving up and down, use your hand, and register the device. Use the number on the devices. And this is the Firebase server screenshot, which all of the informations of the devices will be stored in the server. And each device have a user ID. That's how we keeping track of these devices and data. So I want to introduce my experience data. As you can see, there are two pictures, which is like two experiments during my studies. And the first picture, as the table A, B, and C, is the experiment that I want to find the most efficient and best fit stepper motors in my system to move in the shutter. So I research and take experience on several different motors, and so I chose reduction stepper motor for 5 VDC 5 voltage, and for number A for data A, and the reduction stepper motors on 12 VDC 12 voltage for number B, the experiment B, and the experiment C is for a small stepper, is for small borders in the system. So during this so after study, the reduction stepper motors of 5 VDCs, which is A, experiment A, all of the function perform effectively, but in comparison, though the reduction stepper motors is quite same, 12 voltage stepper motor is quite same as stepper motor 5 voltage, except the voltage and the moving part. The device temperature will increase fast because of the voltage that doesn't fit to the Raspberry Pi, and it will be harmful to the motors and the Raspberry Pi. So And also, in the experiment of type C, it provides less force to move the winches and shutter, and is quite small to fit in the whole system. So as a result, we eventually choose C as a reduction stepper motor for 5 VDC in my system. And the second experiment is I want to find out the working process of the system, um, using the time as the judgment in different weather conditions. So in this case, I choose 3 weather conditions: sunny days, cloudy days, and nights. So I keeping track of the time of moving fully closed in the sunny day in these different weather conditions. By analyzing the movement and observations data, the system would be hesitate during the cloudy conditions because the cloudy days light conditions which would be received by the light sensors, all light sensors would be quite would be quite near our specific data to judge the movements in our Raspberry Pi coding system, in our Raspberry Pi coding segment. So it will cause the shutters moving up for a little bit and moving down for a little bit, which caused the phenomenon called the hesitation, which I just called it. But in the sunny days and night days, the shutters will move in more directly, just moving full up to the homing buttons. So it will also lead us to this experiment also lead us to the future work and the current limitations. So there are still little problems, such as the button and the sensors are hard to get a wonderful places to place, and the force of the winches and lines would be lower than the average level because of the effection of the force of frictions. And also is what I just says about the hesitation phenomenon. So it will be the software's parts, software segments. We need to change the code into a more specific time and set the parameter more specifically. And in order to try my best and fix all of the limitation above, first I was trying to find the balanced places for the sensors and the buttons to have a better looking in a whole looks. And also for the better data conserving places. If allowed, I would also make protection cases for the whole system and make it looking more better and working more stable. And also it is a big challenge that making more generalized of the system and fit with most different kinds of shutters in one of the future difficulties as well. So this project is more specifically control one kind of shutters, which is in the demonstration video, which you can see has long sticks in the middle of the shutters to control the whole shutter. So making more generalized is also a great challenge for me too. And I think it is all my presentations, and thank you for listening.